Welcome back to this channel. My name is Dr. Arzu Jabra. I have a PhD in organic chemistry and I am an organic chemistry tutor. Um, so we'd be actually solving MCAT problems today, right now, or here for chapter 5, which is aromatic compounds. However, I'm also a mindset academic coach for college students, and so, whether you're actually in college right now or getting college blues or preparing for MCAT, that's exactly who I actually help. So, if you are overwhelmed, if you are feeling depressed, if you are stressed out, I help you go from overwhelm, stress, depression to actually feeling more excited, feeling more in control of your time, feeling more focused with your time, with your energy. And I just really wanted to mention why I exactly do what I do. It's because guess who had a hard time in their academic journey? Guess why it's so important for me to be able to take care of other people, other students who are on the path that I was on at one point in my life, right? So I understand the struggles that students actually go through in their academic journey. And until I actually learned the tools, until I actually learned to be high achiever, to be a high achiever, and at the same time feel more centered, feel more focused, feel more driven, and feel more purposeful, feel more connected on an everyday basis, feel like I had something to look forward to on an everyday basis. I felt like it was a dread, right? Until I actually learned those tools, my life completely changed. So I'm on a mission that I help high achievers, the high achieving students, to actually not get burned out. So prevent them from burning out, prevent them from depression. And although I feel like sometimes these lower uh, or these hard times actually are kind of important in our lives for us to so we can actually embrace ourselves with the tools and technology, right? That can actually help us, that can actually, or some of the mindsets tools, um, some of the health tools that we can actually, or some of the conditioning that we can actually change in ourselves to actually show up as a high achiever, but at the same time, a balanced high achiever who's not just really good at academics, but also at the same time, they're very vibrant, they're very excited, and at the same time they're able to focus on other areas of their life that are actually important to them. So if you are someone who is looking for help, feel free to reach out. And of course, I would probably be sharing some more tools and strategies in some of my videos. Otherwise, feel free to check out those in on my channel. And for now, let's get started. So today we are going to be working through chapter 5, Kaplan's organic chemistry problems. And so we are working on aromatic compounds. So the first problem is, which of the following represents the correct structure for para-nitrotoluene? I saw when I was going through these problems that a lot of these problems are not hard problems. They're actually really simple, okay? So I might just like rush through them really fast, and this might be a shorter video just because like these problems are like truly, really simple problems, right? So which of the following represents the correct structure for para-nitrotoluene? So we know para-nitro is like at the para position, which is actually the fourth position. You have a nitro. Okay, so for option C, we see that at the para position, we've got a nitro, and then you have a toluene. Toluene is benzene and a CH3. So the common name for this compound is toluene. And at the fourth position, we have a nitro. So option C is the correct answer for this problem. Okay, for the second problem, which or what would be the major product of the following reaction? Okay, so we've got a toluene again, and this category of reaction is nothing but Friedel-Crafts acylation reaction, right? So in a Friedel-Crafts acylation, we are acylating the toluene ring at what position? So we are acylating it at the um, and also, well, we have a CH3 group present, and we do know that the methyl group is actually ortho para directing, right? So it can only direct the incoming electrophile at the ortho or at the para position. Okay, so then if you think about ortho, the one over position from your directing group, which is CH3 in this case, is ortho, right? Then or the adjacent is ortho, and then one over is meta, and then directly adjacent or directly the opposite neighbor is actually the para position. So we are doing acylation at the ortho or para position, right? So let's check actually. So this is a meta position. So acylation not possible at the meta position because methyl group or the CH3 group, right, is ortho para director, and this is the acyl group. It's not really an acyl group because acyl would just be that, right? CH3C double bond O is acyl. So, but this is more still like an acylation category, but we still have two carbons of that on that C double bond O ketone ring. And so actually, then compound B is actually what has the CH2 and the CH3. So this is actually the para position, right? So option B is actually the correct answer for this problem because that's a para. And then let's check for chlorine. They've added the chlorine and chlorine, which is actually not the correct answer. So we got the correct answer. Okay, so the next is nitration of benzene at 30 degrees Celsius lead to 95% yield of nitrobenzene. When the temperature is increased to 100 degrees Celsius, a dinitrobenzene is produced. Which of the following is a predominant product? Okay, again, so when the first nitro product is formed, right, we have to check whether the nitro group is actually ortho para directing or meta directing. So we know that nitro group is actually meta directing. Therefore, the new one, the incoming one, will be directed at the meta position, right? Because of the presence of an electron with the drawing group, which is the nitro group. Okay, so then option C is actually the correct answer because the first one got the first group is NO2, and then the second one is the NO2, which got added at the meta position, right? At the meta position, okay. And that's why 1,3-dinitrobenzene is the correct answer for this problem. All right, so next problem. What is the major product of the nitration reaction below? Okay, again, we have a nitro group, which is a meta director, or BR, which is ortho para director, nitro group, which is a meta director, and we are doing the nitration reaction. So the more activating of the two groups actually dictate where the nitration will happen, right? And so ortho para directors are more activating, even if it's a weakly activating group, they're still more activating compared to the other deactivating groups. So whichever group is the more activating relatively will dictate where the nitration happens, right? Meaning that ortho para to BR is where the NO2 should actually end up at. And now if we actually really think about it, right, then the NO2 group over here is actually the para position, the only position available because both the ortho positions are actually blocked. Now, if we look at the BR, okay, first of all, in this reaction, because we're doing nitration, BR is like pretty pointless, right? That's why I was saying these problems are so simple that they're not even making like the options tricky. They're not like even making them hard. They're just like adding Br, okay? Now, NO2 group added meta to Br is actually incorrect, right? Because this is ortho and para director. Okay, and then for option D, we have got, again, NO2 group present at the para position. So is B and D the same? Which one was it? Right, okay, so, oh, okay. Did they change the starting material for option D? They did, right? Because they had two nitro groups. Okay, they just changed like the starting material. They just like changed the molecule, but option B then is the correct answer. Sorry, A. I'm sorry, A is the correct answer for this problem, right? All right, next question. What give the predominant product of the reaction below? Now, this category of reaction is Friedel-Crafts reaction, but this is actually alkylation, sorry, bromination. This is a, oh, did I just call it Friedel-Crafts? Yes, it is Friedel-Crafts bromination reaction. Now I'm wondering if the bromination reactions are actually called Friedel-Crafts or just the alkylation reactions are called Friedel-Crafts. Let me double check that really fast. Yeah, it is called Friedel-Crafts. Just whenever a Lewis acid is used, that reaction is called a Friedel-Crafts reaction. So this is a bromination, Friedel-Crafts bromination reaction, right? So then we have the NO2, and now we're using the NO2 at, oh sorry, we are doing the bromination at now that depends on the directing group, the group which is already present on the group. And we know that nitro group is the group which is already present on the group, on the benzene, right? And nitro group over here is actually meta directing. We know that already. So whatever the new group will come in will point at the meta position. This is ortho position, this is meta, this is para, and option D is again ortho. So then option B is the correct answer because that is like the meta position. So for option 6, which sequence of reaction conditions should be used to produce the compound below from benzene, right? So if you've got to start with benzene, we have to add chlorine to that. So we know Friedel-Crafts chlorination should actually be able to add the chlorine to our benzene, right? So I've got a benzene, and so if we add the Cl to that, so our option A, we have AlCl3, Cl2, right? And then the second option is add the hydrogenation rhodium on carbon. And when we actually do that, we'll actually get a hydrogenated benzene with the Cl present on it. One of my favorite reactions are hydrogenation reactions. That is my PhD work for one of my chapters. All right, so then option A is actually the correct answer. Okay, starting with phenol, what is the major product of the reaction sequence shown below? Okay, so for this problem, right, when I was actually looking at this problem earlier, so Kaplan kind of has not fully assumed or fully taken into account that when you have a phenol, right, and then in the second reaction, they're actually carrying out a with the CH3C double bond OCl, what they're really doing is they're carrying out a Friedel-Crafts acylation reaction, which we can already see here. But the problem with that acylation reaction is that when you have a phenol, right, the oxygen has lone pairs, the acylation can actually happen at the oxygen. And this is the same problem with nitrogen as well, right? And the second thing that can also happen is that this is a Lewis acid, so the oxygen phenol can again attack at the aluminum, or can attack the Lewis acid aluminum to create the OAl bond, the OAlCl3 bond, and that would then stop the reaction, and then it will hinder the reaction, or it will hinder the acylation reaction from happening. So they're not considering any of that in this reaction sequence when they're asking you the problem, because if that reaction shuts down, then nothing else is actually happening. And if you really think about this, AlCl3, this is like a second Friedel-Crafts alkylation reaction then, right? So then, okay, this becomes a very deactivating group, and then doing an acylation at the deactivating group is again a problem. It will be a very slow reaction. But when I saw the reaction sequence, what they actually want you to do is just carry out a normal, regular acylation reaction on phenol. So what they really want you to do is just draw this product without thinking about it too much. So acylation can happen. More preferred position would be C double bond OCH3 at the para position without really thinking about it a lot, and then CH3Cl, which actually is incorrect. So I would be surprised if a problem like this actually shows up on the MCAT, because this is not like a fully thought through problem, or I would hope that a chemist would actually be making this problem, and um, and not like, just anybody else. Okay, so then we've got CH3Cl, aluminum trichloride. And then when you actually do that, we do see that we have a O, right? So we've got a lone pair over here. Okay, so same thing. We have an acylation. So that can still be a problem again, but again, just ignore that. So then you want a CH3 over at the ortho position because the para over here is blocked. So then carry out the alkylation, right? And then the next is NaOH CH3I. So for which they want you to carry out a phenol reaction with the base, right? And the OH can actually act like an acid. When that happens in the first step, it will generate O negative, right? Because we are deprotonating the hydrogen of the phenol. And then in the second step, what we are really doing is, after we have got a negative charge, then the negative will actually attack the carbon, kick out the iodine, so to actually form OCH3. Okay, that product. And then further adding the reducing agent, zinc or HCl, that will actually give us OCH3, CH3, and C double bond OCH3. And okay, so the reducing agent will actually reduce the C double bond O, right? Clemenson's reduction. So this will actually reduce the C double bond O, create a CH2 here, CH2, CH3. So then this is the product of that reaction. And what is this called? So this product is actually called 4-ethyl, 1, 2, 3, 4, 2, 6, 4, 1, 2, 3, 4, 4-ethyl, 2, 6 dimethyl phenol, which is not correct actually. 4-ethyl, 2-methyl anisole, which is the option third, is actually the correct answer. 4-ethyl, 2-methyl anisole. Yeah, that's exactly what we got. So the third option is the correct answer. 3-chloro. We don't have chloro, so that's not right. So option C is the correct answer for this problem. Option D. Oh, sorry. Next problem. What would be an ammonium group? How would an ammonium group affect a benzene ring for the subsequent reactions? Pardon, like the different sizes in the problems. But for this problem, right, we know that when we have a group which is positively charged, doesn't have a lone pair, so its tendency would actually be to withdraw the electron density and not to give the electron density. So its tendency is to actually pull away the electrons, right? And so if it's pulling away the electrons, it's deactivating the ring for the electrophilic aromatic substitution reaction. It's not really activating it towards that. And when you activate, or when you actually deactivate the ring, it becomes meta directing, which is the option A. All right, which of the following molecules shown below are aromatic compounds? So if you look at the aromatic compounds, so think about the 3 criteria for the aromatic compounds. The first option is, the first criteria should be cyclic. Second is all carbons should be sp2, right? And the third option is that, why don't you keep calling it options? It's actually the third criteria is that it should follow Huckel's rule, which is 4n plus 2 pi electrons. Right? Okay, so then I hope you can still see my notes here. Now they're all cyclic. They all look like having sp2 electrons or sp2 carbons. Now let's check if they have 4n plus 2 pi electrons, which actually means let's check if we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 pi electrons are not really aromatic, right? So check over here, 1, 2, 3, 4, 5, 6, 7, 8. However, we've got a lone pair here. So 10 then, effectively. So 10 electrons fulfill the 4n plus 2 pi electron criteria. What about over here? 1, 2, 3, 4, 5, 6, 7, 8, and only 8, and that's why that is a problem. So then the correct answer actually would be 4n plus 2 pi electrons, right? Or the 10 electrons are shown in the second compound. So option 2 is actually the correct answer for that problem. And with that, that was the last problem from that chapter, and I will now see you guys next time with the next chapter up, which is I think alcohols, and then we'll go over the problems of that chapter together. And if you want like the PDF of this worksheet that I created, you can obviously download that from all the links that will be mentioned down below. And of course, if you want to work with me, all the links will be mentioned down below. And until then, keep learning, keep growing, and take care. Bye now.